For question 2.4 we have, which one of the following operators is different from the rest? And we're given 4 options here. Now let's take a look at this first one, where first we're using this Pauli class in Qiskit, and we are assigning this label xset. So let's look at the Qiskit documentation, where if we see here, what this generates is an object of type Pauli, and the way it works is if you pass the label, for example, xyz, it will represent x tensor y tensor z with the set operator applied on qubit 0, y on qubit 1, and x on qubit, I assume this was qubit 2. There's a typo right here, but let's go ahead and see what type of operator or matrix we will get if we follow this convention. So let's do here question 2.4, and we were told that if we have, for example, in our specific case, we have Pauli label equal xz, we were told that x will be applied to qubit 1 and tensor z will be applied to qubit 0. So what this means is that we would have the following matrix. So let's remember that our x matrix is given by, or x operator is given by 0, 1, 1, 0, and z is given by 1, 0, 0, minus 1. So if we now do x tensor z, what we will get is, and now I'm going to use some lines here to make things a little bit easier for me to follow. So what we do here, if you recall, is we take the Z matrix here, and we multiply by the first element of x, and that will go in our first block here. So then in that case, since we're multiplying everything by 0, we're going to get 0, 0, 0, 0. And then in this next block here, we're going to get the Z matrix multiplied by 1. So we have now here 1, 0, 0, minus 1. Same here on the bottom left corner, we have again 1, 0, 0, minus 1. And then at the bottom right corner, we're multiplying everything by 0 again. So we get 0, 0, 0, 0. And then this is our matrix, our final matrix. So let's go ahead and look at this in Qiskit. So what we're going to do is from Qiskit quantum info, we're going to import Pauli, an operator, and then from Qiskit tools visualization, we're going to import this array to LaTeX to render things nicely. So let's just go ahead and copy and paste this here. So let's call this operator 1, for example, and we just copy and pasted option 1 here, and let's go ahead and do array to LaTeX of that operator 1, and as we can see here, we get the same matrix we just derived. Now let's look at this option 2, where we have operator of, and now we're defining this Pauli, but only the x label, and then we're gonna tensor that with z. And if we go ahead and do that, we'll see that this is exactly the same as just giving the label. We're tensoring in the right order, so we can do now operator 2. Sorry, let me copy and paste this one. Put it down here, and then let's just render that, and we see that we get also the exact same matrix. Now, let's look at option 3. So in option 3, what we're given is actually a quantum circuit. But if you see here, this quantum circuit is applying an X gate on qubit 0 and a Z gate on qubit 1. And as we discussed previously, the order for this Pauli class is this is applied to the most significant qubit and Z to the least significant qubit. So this is actually in the opposite order of what we had here for the first two options. But we can go ahead and implement this now. Let me just import from Qiskit. From Qiskit import quantum circuit, and let's go ahead and do QC equal quantum circuit with 2 qubits, and then let's do, we said here an X gate on 0, right? So let's do here an X gate on 0 and a Z gate on 1. Let's draw that. We can see here that we have the right circuit, and then let's now do operator 3 equal to operator of our quantum circuit, and let's render that. And we'll see that this matrix is actually different than the ones we have derived before, right? It's in a different order. Now, the last option is this operator. So well, first of all, we know that this is now the answer, right? It's option 3 because it's the one that's different to the first two, but we can also just take a look at this option 4 and define this op4. And I mean, from here we can see that this is going to match that matrix we had previously derived, but we can just go ahead and run it and see that this in fact matches our previous answer. So again, the answer is option 3.